Well, good morning, everyone. I'm Dennis Blair, the chairman of the board of SAFE and a member of the SAFE's Energy Security Leadership Council. And it's my pleasure to welcome you to this webinar on U.S. and allies maintaining semiconductor leadership. Our mission at SAFE is American national security and economic security. The United States is the most powerful country in the world and the largest economy, but in key areas, the important sectors of energy, transportation, and manufacturing, we have developed serious dependencies on foreign countries that are hostile to our values and do not share our interests. And at SAFE, we do the economic, the geopolitical, the technical, the business, and the domestic political analysis to understand these dependencies. And then we find ways to eliminate or minimize them. And then we educate both our government leaders and the public and advocate action to improve the American position. Among the serious American vulnerabilities for which SAFE has proposed action are things like the dependence of our transportation sector on petroleum, the dependence of our growing electric vehicle industry on batteries, and the dependence of key future materials on rare earth metals. In all of these areas, American and other international companies, for very good business reasons, have thinned and spread their supply chains around the world for more efficiency. But the net effect has been to create fragile dependence and have the potential to undermine American economic and national security. And this morning, our focus is on one such area, semiconductors, or chips, as they are more colloquially named. They are these little computers that are in everything from the toys our kids play with up through the most advanced quantum computers that are being built and conceived for the future. Now, the fragility of the supply chain for chips has been brought into focus for Americans in recent months with the delays in auto production due to shortages of chips. And while this is not a 1967 OPEC oil embargo moment, the events of recent months certainly should be a wake-up call to us to look more closely at and build greater resilience into our semiconductor supply chains, both for economic reasons and for national security reasons. These semiconductor global supply chains, and there are different supply chains for different kinds of chips, they are complex, they are worldwide, and they are often thin and tight and need to be beefed up. Now, geopolitics come into play because chip supply chains run through China, which has both some of the manufacturing and is the largest market today for semiconductors, and they run through Taiwan, where most of the most advanced semiconductor fabs or fabrication plants are located. As a former commander-in-chief of the U.S. Pacific Command, I have worked very closely with Taiwan for many years on both its defense capability and its economic needs. Taiwan is only 70 miles from China, and China claims Taiwan as one of its provinces. Decades, it has pressured Taiwan with every tool in its arsenal to bend to China's wishes. And the United States, for its part, is committed to ensuring a peaceful future for Taiwan. And we both assist Taiwan and deploy our own military forces to make Chinese military aggression very high risk and dangerous, which is what it is today. But these military measures are not just for their own sake. They have a purpose: to allow the free flow of international investment and trade. And that flow has been really the key factor in the astonishing prosperity which has come to the countries of East Asia in recent decades, including, I might add, to China. So for our first panel today, we have two real authorities to discuss the US-Taiwan relationship and what that means in terms of semiconductors and economic relations. The first is Mike Splinter, who is chairman of the U.S.-Taiwan Business Council, and he'll be joined by Minister Wang Meihua, who is the economics minister at the Taiwan mission here in the United States. And then for our second panel, we will widen our aperture to discuss the full range of semiconductor supply chains that run through the United States and on which we depend, and the various links of those chains, which are located here in the United States, and those that are abroad, both those that run with our friends and allies on whom we can count, and those that run with more questionable countries and our enemies who actively would use them against us. So our objective for this conference is to understand what the US must do to maintain its economic future in its own hands and to prevent the growth of dangerous vulnerabilities which our enemies can use against us, both against our economic security and against our national security. So let's get on with it, and let me turn over to Mike Splinter. As I say, he's the chairman of the U.S.-Taiwan Business Council. Mike Splinter.
Thank you, Admiral Blair. It's a pleasure to be here this morning, and I'm very fortunate to have with me Minister Meihua Wang. She's head of the Minister of Economic Affairs. And we're going to have a little bit of a fireside chat this morning. I'll ask you a few questions and give you a chance to maybe make some introductory remarks. I think everyone here understands the central role of Taiwan in the semiconductor industry. It's certainly come to light in these last 18 months as chip supplies and the supply chain has become more visible because of shortages in many different industries, most notably in the auto industry. And today we're going to discuss those issues. So Minister Wang, maybe we can start out. I can just say that Taiwan has had tremendous success in building a semiconductor industry over the last 40 years or so. And that success has brought the semiconductor industry in Taiwan to the forefront of economic and political discussions. And many concerns have been raised about this situation. So maybe I can ask you, how do you see the future of US-Taiwan technology, maybe I can ask you, how can Taiwan effectively utilize the centrality of the semiconductor industry into greater economic influence in the global economy? Minister?
Yes, thank you very much. Good morning, everyone. I think the Taiwan-US Technology Cooperation goes beyond the semiconductor industry. The Taiwan-US Technological Cooperation in the ICT industry is worth mentioning here. Over the 30 years, Taiwan's ICT industry has close cooperation with the US company, extending from the OEM to the ODM in the process of manufacturing personal computers, notebooks, and smartphones. Both sides have created a very solid and trusted partnership. And because of this strong partnership, for example, HP and Dell have set up the world-leading laptop and server R&D center, and Intel has also set up its laptop and 5G R&D center in Taiwan. So this highlights Taiwan as the first choice for US technological cooperation. I think the innovation has always been the Taiwan's DNA, because we know that as a small country, we cannot compete with the world without continuous innovation and progress. Based on such good cooperation relationship, we can continue to create more cooperation area in, for example, EV and 5G. Due to the rise of the EV, electric vehicles, Taiwan's strength in the ICT and semiconductor industry has made us a competitiveness partner. We have abundant manufacturing and R&D capability in key electricity system, including the electronic controls, motors, smart driver assistance system, and the Internet of Vehicle. We have become a supply chain partners of Tesla, of GM, and the Fiat Chrysler Automobile, and many other US automakers. And regarding the 5G, based on the future development trend of the 5G Open RAN, Taiwan has already cooperated with the major US netcom companies, such as the Cisco. The US and Taiwan can cooperate in a common standard to facilitate the 5G developments, and that can comply with the cybersecurity standard. Thank you.
Yes, thank you very much. As is noted, innovation takes many different parties, takes trust among them. And it was also noted how complex the semiconductor supply chain is. But I've been wondering, how do you see the future of US-Taiwan technology cooperation evolving? And more specifically, does it really need to be all about semiconductors? That's what everybody's talking about today, of course, but could it be significantly broader and deeper? And in your opinion, maybe, what are we getting right in this relationship and what needs to be improved?
So, yeah, I think I just mentioned about the we can explore in the EV, 5G, and the medicine area for the more cooperation. Based on the such kind of you mentioned about, we already have the deep cooperation in the semiconductor. So the combined semiconductor, ICT, and the Taiwan, the strength manufacturing, the excellence. So I think in this area we can continue for the good cooperation. Yes.
Thank you. And certainly during the last several years, the relationship between Taiwan and China has been changing. It's been quite dynamic. So what challenges is Taiwan experiencing in its economic relationship with China, and particularly in the technology supply chain? And if you could expand perhaps on what role are US sanctions having in this arena?
Thank you. Yes, China is still Taiwan's largest export market. So many people think that Taiwan relies on the Chinese market. But however, Taiwanese OEM companies have set up the production base in China upon the request of the US big brand companies. For example, the Apple is the largest customer of Taiwan's semiconductor industry. And TSMC is responsible for the manufacture of key chips to Apple, which are then sent to China for the assembling of the smartphone. Of course, the Foxconn is the assembly company for the Apple. And facing the US-China trade friction, so the Taiwanese company have been moving part of their production base either back to Taiwan or to the Southeast Asia and India from China. Our government has also actively assisted the business in diversifying their production base in order to reduce the risk of excessive concentration of the trade and investment. In fact, Taiwanese company set up the alternative production base in response to the US company request. And so concerning the US sanction measures, actually Taiwanese semiconductor company, they purchase equipment and key material from the US. They are quite familiar with the US regulation and will certainly comply with the US regulation. We look forward to a more extensive, smooth and transparent communication with the US in order to avoid a scenario that could catch our business off guard. Thank you.
That's great. Thank you so much. And a topic that I've been especially interested in is the bilateral trade agreement. How does the US-Taiwan semiconductor partnership strengthen the potential for a comprehensive bilateral trade agreement? And what other steps are needed to make progress? And if you have a big audience, an influential audience here today, what would you say to them to help move this process along?
Of course, in terms of the advanced semiconductor, the US is TSMC largest customer, accounting for the 80% of the TSMC advanced semiconductor production. But you know, semiconductor related products enjoy zero tariff under the WTO ITA agreement. So as a result, even if the Taiwan-US bilateral trade agreement is not concluded, the related trade will not be affected. But the Taiwan-US industrial cooperation is broad, extending from the semiconductor to the 5G, AI, EV, and many traditional industry. So consequently, some materials and components and equipment involved in these fields are still subject to the tariff. Therefore, lowering these tariff barriers will enhance supply chain cooperation between industry in Taiwan and US. So hence, Taiwan-US BTA is a simple solution to this problem. The Taiwan-US BTA can ensure a more stable investment environment and trade protection for our respective industries. It can further strengthen important role for the development of the semiconductor, ICT, and 5G industry, and such as IPR, protection of trade secret, and other policies. We understand that the Biden administration prioritized the domestic issues, and it has not given the green light to negotiating trade agreement with partners. So therefore we can gather support for a bottom-up approach from our respective industry to demonstrate the demand for a Taiwan-US BTA. This will help to promote a Taiwan-US BTA. And that is why gaining support from participating company today is very, very important. So we need your support. Thank you.
Thank you, Minister. We really enjoyed your insights and certainly wish Taiwan continued economic success and a broader relationship, continuing to broaden the relationship between the US and Taiwan. And I'm sure all the companies in Taiwan and the semiconductor industry are expanding capacity and working hard to alleviate the shortages that we've seen here in the last year. So again, thank you for your time. Thank you for your insights. And I just ask if you have any further closing remarks.
Thank you. Thank you very much.
Thank you. And back to you, Admiral Blair.
Okay.
All right. I think our next segment is a video message from Senator John Cornyn, to be followed by our wider panel to discuss all aspects of the semiconductor supply chain. So let's hear from Senator Cornyn, who could not be with us in live virtual format. So he has recorded this message for us. Let's go ahead and roll it.
Hi, I'm Texas Senator John Cornyn. First, I want to thank Admiral Blair and Safe Commanding Heights for using today's discussion to shine a light on semiconductors and their importance to our national security and economic prosperity. As you all know, there's a clear and urgent need to reorient the way our country views and responds to manufacturing challenges from China. That's why I introduced my Chips for America Act with my friend Virginia Senator Mark Warner to ramp up semiconductor production here at home. If you tried to make any big ticket purchases recently, you know the kind of strain our supply chains are under, and I'm hopeful that this law will help turn the tide. But chips is just one solution. I'm optimistic that with some of our brightest minds in attendance today, we'll see no shortage of other solutions to this pressing issue. Thanks for allowing me to join you, and enjoy the rest of your event.
I'm Jeb Notar. I'm the Executive Director of Commanding Heights at SAFE. Our focus is on advancing industrial capacity in high-tech supply chains, particularly related to transportation and energy for the U.S. and allies. Those supply chains include things like batteries, semiconductors, of course. I want to thank Mike Splinter, and I want to thank Minister Wang and Admiral Blair for an excellent discussion on the geopolitical and geoeconomic aspects of this subject. Right now, you heard Senator Cornyn's remarks. Senator Cornyn is a leader who reaches out across the aisle. He and Senator Warner and Senator Cotton and Rubio and Senator Reid last year came together in the Senate, along with House leaders such as Adam Smith, to pass what became known as the CHIPS legislation. Really remarkable bipartisan action. Every stripe and every faction within each of the parties came together. It's not something one hears in the news about, but it did show a focus and an understanding that we live in an aspect. You may say that our society is a semiconductor civilization. Semiconductors used to be largely things in computers, and we depended on computers. And you had the big, large computers, and then eventually we all had our laptops. But today, semiconductors are in everything, literally. They're in our cars. We all walk around with semiconductors with an iPhone all the time. Sort of the mind-machine meld has already happened. It's in our refrigerators, our microwaves. So basically, our 21st century civilization could not exist without a flow of semiconductors. And today we've got a really excellent panel to do a dive into what is the nature of semiconductor, where do we get them from, what's the nature of the supply chains, and where are we going, and what are some of the implications for U.S. national security and our economic prosperity. So I'm pleased, following Senator Cornyn's framing remarks, to introduce our panel. On our panel today, we have from a leading design company, AMD, John Hoganson. From another leading design company, which almost all of us have used their products over the last 2 decades, MediaTek's Patrick Wilson. And then we have from the Ford Motor Company, which is at the leading edge of has been at the leading edge for several decades in integrating semiconductors and has really very important efforts underway for the future. We have James Rowland, again, from the Ford Motor Company. And then we have Senator Byron Dorgan, retired, former chairman of the Senate Appropriations Committee, someone who has written, I think it's at least 5 books, several bestsellers, extremely thoughtful national security figure, Democrat from South Dakota, someone that has worked extensively across the aisle and is part of our efforts here at SAFE on semiconductors. So I welcome each of the members of the panel and thank you for joining. I'm going to start with a very basic question, and anyone can pick it up, but where do semiconductors come from?
Sure, well, I'll jump in. So again, John Hogan with AMD, thanks for having me here today. Semiconductors, where they come from in the simplest sense, they come from sand, right? That's where they start and they go, but they've gone from this relatively simple substance to something that's incredibly complex, which is ubiquitous, as you say. We like to say that anything with an on-off switch probably has a semiconductor in it, and to be honest, it's even gone beyond that when you start to think about the technology and where it is. There's really 3 major steps to semiconductor production. We like to think about create, design, and build. So the first part is that research, that engineering that goes into making the chip. Then there's the design space, which is where companies like AMD and MediaTek thrive. And it's an opportunity to really take that research and put it into a useful product of the design. Then there's the manufacturing step, right? This is the fab side of things, which is we're actually manufacturing the wafer itself. I've got a visual aid, I'm not going to put it up, but anyway, these are the discs that are cut into chips overall, and then they're put into some sort of useful packaging. And so there's different companies that specialize in different areas, but that's sort of the larger ecosystem that create, design, and build overall. We manufacture some here in the U.S. All the leading edge manufacturing, unfortunately, happens overseas at this point. Countries like Taiwan, Singapore, and increasingly in places like China, where we're seeing more and more of the manufacturing overall. The U.S. It was a leader in manufacturing, and now I think accounts for about 12% of the overall manufacturing of semiconductors. So there is U.S. has a large market share, about 50% of the overall semiconductor market share, but not in manufacturing today. So that question of where they come from, it really is a global industry. It's that ecosystem across the board, but increasingly the supply, into the U.S. at least, is coming from overseas.
Thank you, John, for that good introduction about the actual mechanics of the global supply chain and all the different inputs and intervention places. But I was saying, Jeb, that the real answer to your question is semiconductors are really engineers' effort to eliminate a tedious task, right? If you look about the last 100 years, there were data entry clerks, hundreds of them, rooms full of them, just entering numbers right into ledgers. And the idea of semiconductors was to create a code, a fast, machine-readable code that could simplify really complicated, tedious tasks. And that's exactly what we see today, is that engineers are using technology, semiconductor technology, to solve really complicated tasks and make them simpler. And we see that the very highest expression of that today in artificial intelligence, right? Which is really just the same sort of automation that we've been seeing over the entire industrial revolution, where you reduce the number of human interventions necessary, right? And so that's really what a semiconductor chip does, is it makes complicated tasks simple. And then there's the physical part of it where you actually create the device that does that, but that's what it's trying to do.
Yes, Jeb, let me just make a couple of comments about this issue of supply chain. First of all, with respect to the who, the where, the what does it mean? The who is, here in the United States, I visited the Intel many years ago and heard exactly what they were doing, the invention, the capability, the design, the innovation, chips comes from the United States, but it has moved with respect to a development of a supply chain elsewhere, and that becomes the job. I wrote a book about that. Take this job and ship it. So supply chains used to be, it was fairly new. And then the question about supply chains, what does it mean to us? What does it mean to our security? We've just been through COVID, and all of a sudden, everybody in the country, I think, and probably in much of the world, understands the issue of supply chain as a result of COVID, and masks and gowns and gloves and so on and so forth. The supply chain with respect to semiconductors, it's very different in the sense that the question is, what does it mean to a country if you're not able to access the supplies that are being produced somewhere and then shipped to you? When we talk about supply chain, that doesn't mean that, for example, in China or somewhere else, that's where all the supply is. It just means that that's where it's going to be produced and has to do with cost and price. And so that's the development of these things. And the CHIP Act, which Jeb, you were very involved in, I know, the CHIP Act has been passed, and now it's waiting for appropriations from the Congress. And so we'll see what all that means, but I think that has the capability of substantially changing opportunities for the production of semiconductors and chips here in the United States. One final point, I am from Dakota Territory, but it's north, not south, Jeb.
So, sorry, my friend.
No problem.
Both wonderful states. Well, I'd like to raise the issue of what's the CHIPS Act and why is it important and what are its prospects? Maybe we'll turn to John Hoganson from AMD.
Sure. Well, the CHIPS Act was an effort to deal with the cost disparities between manufacturing in the U.S. and overseas. I think is the simplest way to think about it. There are a couple of studies that have been done, and they've shown that the cost differential can be as much as 30% to manufacture in the U.S. as opposed to some of the other countries. There's a number of reasons for that, sort of a deterioration of the ecosystem here around shipbuilding. But the CHIPS Act was really meant to reinvigorate that and reinvigorate that investment in manufacturing and to some degree in research as well. So it was as part of the it's a grant program that was attached to, created and attached to the National Defense Authorization Act. Bipartisan legislation overall, passed overwhelmingly as part of that. And now Senator Dorgan pointed out is awaiting funding by Congress at this point. The Senate, as part of the competition bill, allocated, I think, a little over $53 billion in emergency funding as part of that. It passed a bipartisan majority of, I think, 68 votes in late May, I believe. I could be wrong on that. And including for our friends at the Ford Motor Company, making sure there's a focus on the automotive side as well. So in addition to leading edge manufacturing, also focus on some legacy pieces, which is a big part of the chips crisis. And it's awaiting action in the House at this point in terms of moving forward.
I would like to turn to James Rowland from the Ford Motor Company on what's important about the CHIPS Act for a great American company. And I just want to note, I've got a few artifacts here. This is an advertisement from around 1983. Shows, if you could see it in close detail, it shows the focus on semiconductor integration in vehicles. Ford's been a leader in this and for a very, very long time. James, could you tell us what's at stake, not only for semiconductor production in the United States, but key product companies like Ford with the CHIPS Act?
Thanks, Jeb. And for the record, I did not provide those props to Jeb in advance, but I think I was fascinated to see them. Look, I'd be remiss to start without thanking everybody on this panel and the Admiral and Robbie and Jeb. Everybody on the panel here has been working to mitigate the impacts. And at Ford, we're the largest assembler of vehicles in the United States, and this has been devastating. And we're not through it. And I just want to level set. The trend is not our friend. And what I mean by that is, while we've been managing as best we can, we're short parts and we're not building the parts and the vehicles that we need to build. So just your point, I just wanted to provide that context that coming out of COVID, where we were down about, in the US industry, about 2 million vehicles, The risk is that we will not, in the United States, we will not be able to build 2 million vehicles this year due to the shortage of the chips. So to add a little context, that's the equivalent of about 8 assembly plants. Nobody would have signed up to say we'll idle 8 assembly plants. Now those plants, of course, are spread across all the manufacturers and different shifts and whatnot. But we really appreciate, full-throated thank you to everybody here who's working on this. It really is we're not through it yet, and it's a big impact to the U.S. economy and the auto production that drives a lot of that. The CHIPS Act is critically important. We recognize that the global constraints are impacting a lot of companies, including the auto sector. And we also recognize the underlying, as the Admiral pointed out in his opening, the importance of securing supply chains for the United States, and that includes reshoring or adding the capacity in the United States. So Ford has been advocating for the CHIPS Act. As you correctly pointed out, we did add a bit of a request that some of the funds be allocated to those companies who also will serve the production of the auto sector. So we're in this. As the largest assembler of vehicles in the United States, we think it's critically important this supply chain and the administration's approach to securing supply chains in the United States is critically important, and we're fully supportive.
Thank you, James. I'd like to turn to Senator Dorgan and get his assessment, looking in the crystal ball. What are the prospects currently look like for the CHIPS Act and the FABS Act right now in the Congress in this extraordinary time?
Well, I think it will get done, but I think there will be substantial appropriations. I think it'll get done because it's bipartisan. But what has happened here in the Congress is there's this unbelievable focus, first on infrastructure and then second on reconciliation, especially by the Democrats. And Democrats, of course, control the House and the Senate. But what has happened more recently, and by the way, there's a fire alarm sound going off just outside my office asking for evacuation. So we'll see how long I'm going to be here. But let me say this. With respect to the supply chain issues, I think Jim talked about somewhere there's 1,000 chips in a car, something like that I read recently. That's unbelievable. And this is about national security, and it's also about economic security, both of which combine on this issue of semiconductors. So my understanding is my door is opening and they're asking me to clear out of here. I assume it's probably not a fire, but it's a fire alarm at the moment. So we will see. I apologize for that, Jeff.
Well, we adore chips, but we also, you're a national treasure. So please make haste.
Well, thank you very much.
Thank you, sir. Thank you for their assessment. Follow-up question on the CHIPS Act I'd like to pose to Patrick Wilson is, since it's likely to get passed, what's the preparation that U.S. government departments and agencies should start doing now so they can implement when they get the funding and deal with this crisis?
Well, thanks, Jeb, and I'm excited actually to hear the senator's assessment that he thinks that this will get done this year. There is a lot of pressure on the budgetary process, and trying to do something we shouldn't miss. This is an extraordinary change in U.S. policy to have a new federal grant program, and it goes to the point, Jeb, you were making about getting ready for it, because never in our nation's history has there been such a complement to an economic development policy like every state has, right? Talk to any governor or any politician that's been a governor, and they'll understand that states have economic development officers that do nothing but talk to international companies like ours or companies like John's or Ford and try to entice them to come to their state. But they've never had a federal partner before. And so this is really a brand new task for the Commerce Department. The good news is they don't have to start from zero, right? Because they already have these incredible partners in the state economic development officers who already understand, how do you vet projects? How do you rank them? How do you assess ones that are successful or likely to be successful from others? And that's exactly what the Commerce Department and its new institutions they're building are going to have to create, right? Is how do you assess potential investment projects, whether they're in research or design or in manufacturing, which is so important. How do you assess what federal money should be coupled with state and local incentives to make a project happen? I know that Secretary Raimondo is already at work building some of this infrastructure inside the Commerce Department, since the bill is already authorized, but of course they can't take action until it's fully funded. And that's what folks like John and myself and James and others are all working on, is to get that funding approved. Something you said earlier, Jeb, comes back as a national security issue too, is we have to remember that our close allies are also not standing still, right? Every one of our close allies, Japan, Korea, Taiwan, and the EU, they are also building simultaneously their own semiconductor incentive programs, right? That are making their way through their respective legislatures. And that global competition for where capital will be invested is real and intense. And if you're wondering, well, how does this make it into the top level of priorities for Congress? That's the reason, right? Because it is about where capital will be deployed. I think it will be deployed in the places that are most advantageous. And the US government has to get in this game, because we, at this point, are the only OECD country with existing semiconductor capacity that doesn't have a federal incentive program. So I think the pressure is just continuing to mount on the US to get in the game and to help steer a lot of that capital that's being accumulated by this huge chip surge we're living through, to get it deployed in the United States.
Patrick. John, I'd like you to follow up, because I know you've got a number of thoughts on this.
Yeah, thank you. I'd just like to add, I think that we need to be thinking about the whole ecosystem. The CHIPS Act is a great step forward. It's really focused on manufacturing. And like I said in the beginning, we're really focused on those three aspects that create, design, build of the semiconductor process. The reason that it's cheaper to manufacture in Taiwan or South Korea is part of location, but also because they're very good at what they do. And it's been a 20+ year investment or longer to build that ecosystem around semiconductor manufacturing in those places. The US is underinvested, and we need to think about the CHIPS Act as the start of that. So when you think about implementation, we're hopeful that the administration and Congress will be thinking about this as a first step in building out that larger ecosystem. We need to be investing not just in manufacturing, but also in the research side of things, the workforce components of this. And developing the next generation of technologies to maintain that leadership by onshoring a lot of this, by building out that ecosystem. Ultimately, those costs will come down, and the U.S. can continue to maintain its leadership position overall. So it's really about building the entire ecosystem. Here in the U.S., CHIPS is a great step forward in terms of manufacturing, but we need to be thinking longer term and really thinking about a longer strategy.
Thank you, John. Sort of a way that I think about it is a little chart that we use. In the upper left, you've got, the issue of design. Companies like AMD, MediaTek, Marvell, Qualcomm, Excelon. In the upper right, you've got fabrication, Intel, TSMC, Samsung. And then in the lower center, you've got the companies that do the productization and integration. This is the companies like Ford, the companies like Areva that build out our infrastructure. And that all leads to the products. So essentially, in this triangle, this is an ecosystem that has got many dimensions, many aspects of supply chains. It's global. We would like to see more of it in the US and allies. We don't want to see it all go to China. But it's very intricate. And it's powered by people at the end of the day. Like, where is the talent? Where is all the tradecraft resident? So following up on the nature of the ecosystem and what the CHIPS Act can do to level the playing field, I want to ask James Rowland from Ford, what can we expect? What's the new frontier with cars? What can we expect over the next 5 or even 20 years? And what is a vehicle going to be like with all these semiconductors?
Well, if you Google the future of the auto industry, Ford is there, but all the manufacturers there with really exciting developments. We talked about the billions of dollars to the race to electrify our fleet. But parallel to that is AI and assisted driving to fully autonomous driving. All of that will be chip-rich products and modules, and it's going to provide the type of connection for consumers that we come to experience with our phones, for example, when you get in a car. So all of that infotainment and increased reliance on electrification and automation drive a huge demand for chip and new innovative type of chip engineering in our vehicles. And that's the most exciting part of the work that's ongoing right now. We're also managing through this bit of a storm right now of trying to build the vehicles that we're trying to get out the door right now, which is a constraint for us right now. The future is bright, and that points to, again, the conversation you had about economic security and domestic, shoring up our domestic supply chains for this work in the United States. And I'm add one point that wasn't made by Patrick or John was part of the CHIPS Act needs to be targeted to those companies that already are manufacturing in the United States. There's a sense that the CHIPS Act will have a lot of greenfield projects. It will. But we know for a fact that there's a lot of good companies out there that need to retool, and they should be provided access to these incentives. Those are critically important, to your point, Jeb, earlier, which is anchoring those companies that are already here and doing a great job, including for the auto industry.
Thank you. We have Senator Dorgan back, and the question I want to pose to him is, what is the national and economic security interest that we see between semiconductors at one level upstream, but downstream all these other industries in the United States that depend on semiconductors?
Well, I mean, obviously the economic issue, I think, and national security issue that Dennis and James and others have talked about is so critical and so important. The issue of where these things are made, when they're made, how they're made, how soon can you begin to ramp up manufacturing, so on. There's been a lot of discussion about that, and not necessarily a significant agreement. And I'd be curious, as we talk about this as well, will this issue of semiconductor shortages, will it finally get through 2022 and perhaps be in our past? Or is it going to stretch into all of 2022? Is it going to stretch into 2022 and beyond? My understanding about this is it takes a great deal of time to produce a manufacturing plant that is significant and of consequence, so that we're not going to be able to see this resolved quickly. And so even as we start talking about what is the economic security when you can't build automobiles, or you can't find the semiconductors for the products that you telephones or laptops or you name it, the national security side is that we need chips in fighter jets. We need chips in military equipment as well. So there is an economic and a national security interest that literally demands our country do something. And that's what the CHIPS Act is designed to do. It will, I should go back again and say, I believe it will get funded, authorized and funded, but it will, these things in most cases now become part of omnibus packages at the end of the year to provide funding right at the end of the year for the following years. It's the wrong way to do business, but unfortunately, it's the way the Congress has begun doing business for the past decade.
Patrick from MediaTek, do you have some comments on the issue of how quickly do you develop capacity to meet a shortage? What can be done in reality?
Well, I mean, I would correct one thing you said, Jeb, which is, we're living in a shortage, and with apologies to Jim, right, and Ford, yes, there are shortages, but what we have to think about is this is the greatest demand surge in human history for technology, right? It isn't that we have a limited supply. It's that companies are producing 50% more than they did last year. And last year was the greatest year in the history of the semiconductor industry, right? So it's an incredible demand surge. Everybody getting online for school, everybody getting online for work, everywhere in the world at the same time. it's really an extraordinary period. So there was undoubtedly going to be stresses in our supply chain because of this incredible growth. But particularly, Jeb, to your question about what about the manufacturing or about capacity, for fabless companies like John's and mine, right, we're some of the largest fabless companies in the world, we care about that overall global picture of what manufacturing capacity is available. We use global foundries, we use TSMC, we partner with these manufacturers, and as they add factories, and it takes, as Senator Organ said, 3 or 4 years, right, to bring on new capacity to respond to demand, it's really a challenge, right, to see these surges in demand and to get that capacity online. And there are no factories, no chip fabs really anywhere in the world that have spare capacity. They're working 24 hours a day at 95 or 98% capacity. And that's just a reflection, again, of that huge surge in demand. One of the things also that Senator Dorgan said that I think is important for us to remember is that from a national security perspective, our government and their customers like DoD, they ride on the innovation that comes from the private sector, right? Yes, we care about the F-35 and it's important, but those are not leading edge chips. Those are mostly maybe 4 or 5-year-old chips, right? The cutting edge chips are in commercial products. And so, DoD really cares about where their next generation is going to come from. And that's the advice I give to every single political official, any policy person is, anytime someone comes to you and pitches an idea, whether it's the CHIPS Act or anything really, you have to ask yourself, will whatever you're asking for, is it going to make it more likely that innovation will happen here versus somewhere else, right? And everybody has a favored policy, whatever it is. And I wish politicians would ask, does that make it more likely innovation will happen here versus somewhere else that's more competitive, that applies on tax policy, regulatory policy, incentives like we're talking about from the CHIPS Act? It's really a binary choice. Where will innovation happen? Because rest assured, really great companies, they're going to serve their customer. Count on it. Count on them serving their customer. The only question for policymakers is, from where will they serve their customer?
Jeb, Byron, can I just add one point quickly? And that is, China has the 2030 plan and so on with respect to semiconductors. It's also the case, I would say, Patrick, that in China, the state-owned enterprises, SOEs, those SOEs are putting massive quantities of investment and money into these issues. And so we have companies competing against a country with state-owned enterprises. That is not the kind of competition most people believe represents fair competition. So you're correct that there are a lot of things that make a determination of where something is produced. But what is happening in China and between now and 2030 with state-owned enterprises is quite remarkable and quite serious.
Yeah, I think that's a good point.
Jeb? James here from Ford, wanted to jump in, just building on Patrick and John's point, and also, Senator, to address your forecast. What we're stepping into now is the tension, or the present and the future. We've sort of 1 foot in the future and one in the future, in the present and one in the future. The challenge we've got, just to level set, is that in September, IHS, who tracks global production forecast, downgraded the global production forecast by another 5 million units for 2021, taking the risk to US production up to about 2 million. And to the senator's question, they also didn't see a relief for auto production until the second half of 2023. So I get the point that Patrick's making, and we appreciate all the efforts, but something doesn't add up when we see the abundant flow through the supply chain, and we are seeing some of that. But on critical parts, some of the legacy nodes, for example, the modules we've tested and used for years, we are not able to source those components. So I wanted to point to something else that the government is doing. While we applaud and fully support the CHIPS Act, the Secretary of Commerce has launched a request for information to gather those inputs, both from the demand and the supply from the US industry, to understand what the demand is, what we'd like to be building, and then where that's coming from. And we're fully supportive of this. This is a transparency initiative. that we hope will shed some light on some of the constraints that we've got, because commerce is also focused on the here and the now. We are facing, if the risk of IHS plays out and we have a 2 million vehicle constraint for 2021, that's equivalent to about 8 assembly plants worth of output. That's the here impact. That's the now impact to the US economy and the sector that generates about 3% to GDP. So there's a tension here. We fully support the future, but we have to have one eye on the here and the now. And if we're not going to be able to produce the vehicles that we've got scheduled up until maybe the second half of 23, that's an impact to the economy that we can't ignore. I just wanted to make that point.
I would just like to add that sometimes my own experience in industry on the product side, aerospace and defense, sometimes the legacy nodes, these are the older nodes, sometimes 10, 20, 30 plus years technology level. It's still amazing technology. It's enough to, you know, power a Boeing jet or to put a person on the moon. But a lot of the legacy foundries, one of the problems is they're smaller. Because they're smaller, they don't have scale, they're costly to run. Sometimes they don't attract the talent that a massive foundry in Arizona that is producing exponentially more chips at the leading edge draws. So the legacy foundries are they're a real challenge in the country. And sometimes we've not found the business model that quite makes it work as it should for a lot of industry, which is using a lot of those legacy nodes and really the government and US military systems.
And just to add to that, those legacy nodes often are the ones that have the durability and the safety testing that is required by law in the US auto industry. So I got your point, but there's a reason why they're legacy. They've had longer development time to be safety tested for our to meet US safety laws. So that's one of the tensions here, is those legacy components. To your point, and I know Patrick's nodding, and we've had this other conversation, that they work really well. And we can't move off of those on a dime. We need some room to move it. As you pointed out with those pictures, we can absolutely engineer, and we are leading in the engineering for the development of the auto industry. But we also can't be handcuffed and cripple the US economy when we can't get those parts that we were asked to durability and safety test. So there's a tension here. And I think that's one of the points that policymakers have to balance. There's the here and the future, and we're trying to do both.
Yeah, and Jeb, I was going to say too, you know, you think about companies like Ford Motor Company in the middle of the pandemic. I was in the Office of the Secretary of Commerce, and I feel for them. You know, Jeb, there was a time that we were threatening to close them and make them make ventilators, right? We were literally using the power of the government to close those factories. They canceled orders and got out of the queue as well. And that really impacted the auto sector in a unique way, because government intervention, but also, you know, just hard to anticipate what consumer demand was going to change. And also to Jim's point, I think about the legacy chips, please don't forget in this, John mentioned this before, but if you came away from today's panel and didn't hear this again, I really think listeners would be cheated. And that is, workforce is everything. We care, all our companies in the semiconductor industry, we care about research and development. Ford cares about R&D because that makes engineers. If America doesn't produce more engineers, we are not going to be the locus, the situs of innovation. It all comes down to that. Those men and women who pursue scientific endeavor as a career, we all work for them, right? And if as a policy, we don't support the development of those engineers, we're not going to be able to serve our customers from the US.
Hey, Jeb, if I could just jump in one last point here. I mean, this started around a conversation of sort of the economic impact of semiconductors. You know, some folks making a safe connection here, some people have noted that semiconductors are the new oil, right? I don't know if I go that far, but certainly they're strategically very important and they're economically important. And I think the US is just starting, lawmakers and others are just starting to wake up to the importance of this. It's an incredibly complex supply chain, incredibly complex thing to manufacture. We're literally manipulating electrons and atoms and everything, and we're making our products at the end of the day. And so there's a lot of work that needs to be happening here, but I think it all starts with these conversations, and it's a really positive conversation to be able to have this and figure out what we need. We have sort of a short-term problem in how we deal with the the acute shortage in the auto sector and other areas, but it is a longer-term problem in how we keep maintain the ecosystem around here so we can maintain U.S. leadership going forward. So, I think this is exactly the right conversation. It's how do we make sure we keep this competitiveness going forward? But I think, in many ways, people were sort of didn't understand how important they were. In our pre-conversation, Patrick was talking about, we've been doing this a long time. He could light himself on fire talking about semiconductors and no one noticed 10 years ago. Now, we're the hottest thing in town, if not, globally. It's kind of cool. There's a lot of work that needs to happen here that we need to focus on to make sure that we're getting it right.
I would echo that, John. I think this is a kudos to Robbie and the Admiral for convening this panel, and this is an important conversation, how we manage this. And kudos also to AIT in Taipei, the American Institute there, and Minister Wong and Representative Shao here in DC, who have been instrumental in that communication flow. And I applaud SAFE for having the minister on this morning. So we would definitely support future conversation like this. And this is critically important. And again, the balance of the excitement of the future, but the constraints of the now. Those are the types of things that we know we can put our heads together and solve this. So we just need to have more of these conversations.
Thank you.
You have to feel for members of Congress who are fighting out these priorities, right? Where to make room for this in the middle of these big fights on Capitol Hill right now about what the nation's priorities are. And while we're giving thanks, we should certainly not forget Congresswoman Doris Matsui and Congressman Mike McCall are two really tireless House champions who are in there fighting it out, saying, yeah, we care about reconciliation. Yes, we care about infrastructure, but we have to keep a focus on winning this superconductor fight. And I know we're all very grateful for the work that they have done to keep this on the radar of their colleagues.
Thank you. I think this will be the first of several conversations we're going to have on semiconductors and microelectronics, because there are several important dimensions. There's the issue of, for SAFE, very important U.S. military systems and critical infrastructure of the government, the difference in commercial and government practices. So we're going to do several of these over the next few months. I also want to note we have a question from a Princeton University workshop that's doing a report for the Department of Commerce on resilience of U.S. domestic semiconductor supply chain. I'd like to pose it to our panelists, and I think this is an important one, especially since we talk about U.S. and allied capacity. And a lot of these allied companies, I want to note, they've got production right here in the U.S. It's absolutely vital, cutting edge, employing thousands of Americans. It's really wonderful cooperation. So the allied portion's important. I want to pose the question from the Princeton University workshop. What does the U.S. need to do to strengthen cooperation with our allies in the semiconductor supply chain? And what's the right balance to be looking for in terms of increasing domestic capacity and the use of these allied companies?
Well, I guess I'll jump in, being representing a company headquartered in a closely allied U.S. country partner. So MediaTek, is headquartered in Taiwan. We're right next door to TSMC, our manufacturing partner in Hsinchu in Taiwan. But what I'll tell you is, first of all, I'm gonna do something unusual. I'm a Republican guy from the Trump administration, but I'm gonna compliment the new administration. Actually, they have continued the policies we built around technology in a lot of good ways. But the important thing is they've put semiconductors on the multilateral discussion list. We just had a great Quad conversation. We had bilaterals with Korea and with Japan, and semiconductors weren't just, item number 11 on the list, because we have lots of security challenges, lots of areas to cooperate. But semiconductors was placed really, the issue of semiconductor cooperation was really moved up to the top 4 or 5 national security issues. And I think that's really, really good news. And again, for close allies like Taiwan and our partners in Korea, Japan, and Europe, that's just a great thing that our diplomats are being empowered to raise semiconductor cooperation at that highest level, which is a good sign. But what you have to do is, this is again, me sort of freelancing here, but I will say that you also have to get really close alignment from our allies on why this is important, the urgency of having a uniform system, right, that we all agree to. Because going it alone, the US just trying to unilaterally control innovation, it's just not possible, and it's not fruitful. It really disrupts the market. And we didn't talk about that on this call, but hopefully on a subsequent call we can talk about it, is that when government wades into these complicated supply chains, sometimes they can inadvertently make things worse rather than better. And coordination across our allies to get a regulatory environment that is uniform, is focused on the right things, that is a really important part of reducing supply chain uncertainty, reducing capital uncertainty. Again, where are you going to deploy capital? Getting a uniform regulatory environment is really important to that, and that's worthy of a whole seminar in itself. But I'm glad to hear that group at Princeton is focused on that, because getting everybody on the same page, all our close allies, is an important priority, and it does look like this administration has made that a priority.
Thank you.
Jeb, let me just say that this is a disruption. We have a panel discussion because of what I think is a very significant disruption. And the question for every country, including especially ours in the United States, is what does this mean for us? What does it mean in terms of our economic growth, our national security, our economic security? And that's why I think in public policy, it's important for Congress to take a grip and look at all of this and decide what is it that we can do to respond to this disruption, because the disruption now exists, and as Jim has indicated, will probably exist through all of next year and maybe beyond. I think public policy here is very important. I think the Commerce Secretary and others reaching out to our allies is very, very important as well. And the issue of the supply chain in this case is very, very important. It's not a supply chain like someone producing toothpicks or ear swabs. I mean, this is really, really important to our country's future. And so we need to get this right.
Thank you very much, Senator Dorgan. I think well said. I want to thank each of our panelists, Senator Dorgan, John Hoganson from AMD, James Rowland from Ford, and Patrick Wilson from MediaTek. Really, this has been a tremendous discussion. This will be the first of several that we do. And we've hit on a lot of subjects, domestic and international. They're really vital to American prosperity and that of our allies. With that, I'd like to now turn to SAFE CEO, Robbie Diamond.
Well, thank you so much, Jeb. And thanks to everyone who participated, from Admiral Blair to the Minister, Mike Splinter, the panelists you all just saw, and thanks to the staff who put this together. I would like to close by putting it into a little more context of the organization. SAFE in 2004, when we were founded, really, as Admiral Blair said, focused on oil and how we had this dependence on oil and couldn't live by our values with every major military issue. In recent past, global war on terror, 2 hot wars, every major recession being preceded by an oil price spike, and that we needed to do something about it. So we brought together former 4-star admirals and generals and CEOs from major companies who could advocate for how do we produce what we need in America with high environmental standards, use it as efficiently as possible, and ultimately diversify to electric and other types of vehicles. And but really at the core of our mission was, how do we live to our values? How do we make sure that supply constraints don't force us and force our hand in ways that we wouldn't want? And really the expansion of SAFE in many ways to some of these questions is not a change of what we're doing, but rather the changing nature of technology, but getting to the core of what we wanted to do initially. When we're thinking about this, I like to now shorthand say, if it's in the F-35 and it's in a car, we should be for it. We should care about it, whether that be the minerals, as you heard from Admiral Blair, the batteries, semiconductors, or the aluminum, et cetera. And yes, there'll be more advanced chips and less advanced chips, but in the end of the day, we need chips. It was said that that they are the new oil. Others have said that they're the new breadbasket of Rome. Paul Kennedy, the historian, and that if why did Rome fall? They'd lost their breadbasket, and we can't do that. And what's been so striking to me as we've been working on this is really how it's not just about innovation, but innovation happens with manufacturing. And so really you innovate where you build. And so these two things do need to come together at some point. And so we need to care about not only that we're the most innovative chips, but also that we do build some of our chips, not just ourselves, but as we heard with Taiwan and our allies. And I do think this ecosystem, and it's been a fundamental change. Jeb said that we'll be doing more of these. It's true. We are going to start a semiconductor center at SAFE. We've just started a critical mineral strategy center that has a tremendous amount of support at the moment. We have a private donor who would like to do the same with semiconductors. And we bring this unique voice. We're not just a think tank, but we care about the thoughtful work, but we also bring the greatest advocates to the table who aren't being paid to do this. It's because they really care about our country, our values, and our allies. So we look forward to working with everyone on this call who participated in the panel, and hopefully people who are listening, and allied countries around the world who want to make sure we have the appropriate ecosystem to keep the semiconductor supply chain flowing like oil. I mean, it's incredible that our cars had to stop because we didn't have the oil, and now our cars are not going to be built because we don't have the semiconductors. And to me, that is why we're so passionate about not just this area, but also batteries and other minerals. So thank you everyone for participating. It is the beginning of the CHIPS Act, then you're figuring out how to use the CHIPS Act money. First, got to get the money, and then ultimately this conversation is going to go on for a very long time. And bringing both the military needs, but also the industry needs and our commercial needs together is really going to put the United States and our allies in a strong position. So with that, I will end, and go out there, call your Congress person, especially in the House, and tell them that they need to add the CHIPS Act to whatever they get passed this year. Thank you so much, everyone.